All right, so we're still on worksheet 9.3. We're on question number 15. This one's a little bit, I don't know, I don't think it's that tricky. It's a concept we learned back in algebra, but we're kind of tweaking it a little bit. So let's look at question number 15, okay? So, and I'm recording here, so just to give you guys a heads up on that. Okay, they tell you this is a geometric sequence. They tell you that, okay? Otherwise, you wouldn't be able to do this. Excuse me. And they tell us on number 15, they tell you a sub 4 is 3, and they also tell you a sub 6 equals 9. Okay, they need to find the common rate. Okay, so how the heck are we going to do this? All right, so what we're going to do, I'm going to go back to algebra 2 right now, or actually algebra. If I give you this right here, 3x plus 2y equals 7, and 2x plus 4y equals, let's see what I want here. I don't want 7. Let's do, 7's good. Is that what I want? Now let's do this. Negative 3x plus 4y equals 5. Okay, if I give you that, how would you guys solve that? Uh-oh, yikes. Add them together, yeah. Remember the elimination method? You have 6y equals 12 and so forth. Now, I think I taught you guys this earlier this year. If not, I might have taught it now in algebra or FST. We always, in algebra 1, I always add. I always said always add, okay? Then in algebra 2, I think I say this. If I gave you like 5x plus 2y equals 1, I'm not going to finish this out. 5x
Yeah, it was
plus 8y.
trig, I think, is the first time you tell us you
Okay.
can subtract them.
You can subtract them, yeah. Like right now, if I added them, I wouldn't want to add them up because what would cancel?
No.
Nothing, okay? You can, now what I do in algebra 2 is I say, okay, let's times everything by -1, then add them up. I say it's always add, always add. But then I told you guys in FST, you can subtract, you can do that, okay? So I don't do that in algebra 1 or algebra 2 because I'm afraid some students will like add over here, then subtract over there. I just say add every time, always add. Well, if you want, you can subtract. You can subtract. That also works with multiplying and dividing, okay? You can multiply these and you can also divide these, okay? As long as you do the same thing on both sides, okay? So why do I bring that up? Well, let's do this, okay? And I'm going to start with, which one? I'm going to start with the lower, the higher one first, okay? Using the formula, G sub n equals G sub 1 times r to the n minus 1 power. Okay, using that formula, okay, let's start with this one. There's a reason why here in just a second, okay? I want the bigger values first, okay? 9 is bigger than 3, the 6th term is bigger than the 4th term. It's just, I think it's a little easier if you start with the bigger ones. So, they gave you a sub 4 and a sub 6. I don't know why I wrote those down. I'm going to change them to g's, okay? I just think it's confusing because then it looks like it could be arithmetic, okay? You know it's geometric because it says it's geometric. I'd prefer to use g's rather than a's. Okay, it just makes more sense to me that they would do that. Okay, so I'm going to do this. I'm going to plug in G's, G sub 6 equals G sub 1, I don't know, times R to the 6 minus 1 power. Okay, now underneath that, I could rewrite this. G sub, it says G sub 6. What could I put for there instead of G sub 6? 9, I actually put 9. It is 9. Not G sub 9, 9. The 9th term, the 6th term is 9. So 9 equals G sub 1 times R to the 5th. I'm going to circle that. Okay? Off to the side here, I'm going to do the same thing here. G sub 4 equals G sub 1 times R to the 4 minus 1. Okay? And we can simplify that. G sub 4, I could replace G sub 4 with 3 equals G sub 1 times R to the 3rd. I'm going to circle this. All right, now I'm going to stack these things, okay? I'm going to write this one. You could just put this over here. I'm going to write it twice. 9 equals G sub 1 times R to the 5th. 3 equals G sub 1 times R to the 3rd. And what I'm going to do is I could add the sides, I could subtract the sides, I could multiply the sides, I could divide the sides. I'm going to divide them. I'm gonna take this divided by this equals that divided by that equals that divided by that. Why would I do that? Why would I divide? What's gonna happen if I divide? Do I see it?
1 times R.
What do you mean by 1?
Because you get G of 1 over G of 1, which
G
is
sub,
1.
which what?
Which is 1 times.
So they basically what then? They cancel. The G sub 1's cancel. You said you just said 1. Did you say G? No, the G's go away, okay? Take this, divide this by this, divide this by that. If I do that, we get 9 divided by 3, which is 3. G sub 1 divided by G sub 1 is 1, which is just nothing. I mean, it's 1. Okay, I'll write 1 there, what the heck? Times, what's R to the 5th divided by R to the 3rd? R to the 2nd. When you divide, you subtract. So we have 3 equals just R squared. And the last thing you have to do is square root. And when you square root, don't forget, and they give you a little bit of a clue here. It says, find all possible values of R. Okay, so we need to put our plus or minus symbol there. Okay, so R is plus or minus radical 3. Now this is done. I remember thinking, okay, but whatever, yeah, we did this, but what? Radical 3 plus or minus radical 3 is the rate that they're timesing by, okay? So look, this problem's done, but if I give you this right here, G sub 1, G sub 2, G sub 3, G sub 4, 6. G sub 4 is 3, G sub 6 is 9. So if let's say positive radical 3, let's say it's positive radical 3. To get this term, I take this and I times by radical 3. So take 3 times radical 3, that's just 3 radical 3. Now how do I get this term? I take this and times by radical 3. Well, what's 3 radical 3 times radical 3? 3 radical 9. And what's radical 9? 3 times 3, which is 9. Now what about the negative 1? Well, what if it was negative? If I took 3, and again, there's possibilities here, okay? If I times by negative radical 3 times negative radical 3 is negative 3 radical 3. So negative 3 radical 3. To get the next term, I times by radical 3. Not radical 3, negative radical 3. A negative times a negative is a positive. We just did this. We're going to get positive 9. Okay? So what we're getting at is this, okay? Is this next term 3 radical 3 or negative 3 radical 3? It depends. It depends on what the rate is. The rate could be positive radical 3 or it could be negative. We don't have enough information. Okay? We don't have enough information. Okay? So I'll tell you what. I'll do an easier one here. Maybe this will make it a little bit easier for you guys to see. Okay? If I gave you okay, do you know what my common rate is here? How would I go from 1 to something, then to 4, then to something, then to 16, then to something, 32? Any idea what you think I'm doing? And we're doing it geometrically. We're timesing by something. Times by 2? Times this by 2, what do you get? 2. Times this by, times that by 2, you get 4. Times that by 2, you get 8. Times that by 2, you get 16. Oh, shoot. Okay? Times that by 2, you get 32. I made a mistake there, sorry. Okay? Now, you might be wrong, though. It might be times by negative 2. If I times by negative 2, what's 1 times negative 2? Negative 2. Times that by negative 2, you get 4. Times that by negative 2, negative 8. Times that by negative 2, you get 16. Times that by negative 2, you get negative 32. So again, am I timesing by 2 or am I timesing by negative 2? I don't know. There's not enough information there, okay? So that's what we're saying. There's more than one right answer. Your rate can be radical 3 or negative radical 3, okay? So get question number 17. Okay, it says, find the sixth term of the geometric sequence whose first two terms are 4 and 6. Okay, so they give us the first two terms are 4 and 6. So G sub 1 is 4, and G sub 2 is 6. They want what? The sixth term. I want G sub 6. What is G sub 6? This is a very typical test type question. This one really shouldn't be that bad at all, okay? So what we're going to do is this. First off, we can find our common rate, okay? Our common rate, remember, you take any term and divide it by the one in front of it, if it's geometric, and it is geometric, okay? So I'm going to take the second term, 6, and divide by the one before it, 4. 6 divided by 4 which is 1.5, or you can make it 3/2, I don't care. Okay, so how do I find g sub 6? We use again the formula g sub n equals g sub 1 times r to the n minus 1 power. So g sub 6 equals g sub 1, which we know, times 1.5 to the 6 minus 1 power. So 4 times 1.5 to the 5th. You guys got calculators on your phones. I don't know what the answer is there, so you guys want to type that in? 4 times 1.5 to the 5th power. See if I can figure this out. $30.375? Okay, 30.375. Okay. Cross off 18 and 19, we're not doing those. Cross them off, 18 and 19. If you want to, you can cross off 25 and 26 as well. And if you really want to, you can cross off 47 until the end on the back. If you really want to, we're only going as far as 46. Okay, all right, question number 21. Now we're getting into geometric series. Geometric series, okay? Now, I'm going to start out by doing this a little bit longer way, which is not super long. And then hopefully you guys will be able to see that there's a shortcut on how to do that, a little bit of a shortcut on 21. Okay, so we have sigma from k is 1 to 10 of 3 to the k power. Okay, all right, so the formula we're going to use, S sub n equals g sub 1 times 1 minus r to the n over 1 minus r. Okay, that is the formula, right? That I gave you guys, yeah, 1 minus r to the n over 1 minus r. Okay, all right, so on this one, okay, if it's easier, you might want to actually come up with some actual numbers here, okay? So to find the first number, you plug in 1. 3 to the 1 is 3. Sigma means add, okay? To find the second number, you plug in 2. 3 to the second is 9. Plus, to find the third number, plug in 3. 3 to the third is 27. Plus, to find the fourth number, plug in 4. 3 to the fourth is 81. Plus, dot, 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 it eventually ends. There's going to be 10 of them. There's 10 numbers, okay? So, the sum of those 10 numbers from 1 to 10 equals g sub 1, which is 3, the first number was 3, times 1 minus your rate. Well, your rate, how you go from 3 to 9 and 9 to 27, 27 to 81, we're timesing by 3. To the 10th power over 1 minus 3. Okay? We're going to use our calculators when we need them, okay? So use a calculator when you need them. Don't use them when you don't need them, okay? So, here's what we're going to do. 1 minus 3, we can do that. So we have 3 times 1 minus 3 to the 10th over negative 2. Okay? Now, one more thing, okay? We can simplify this. This 3 times this 3 is on top, okay? I could simplify 3 over negative 2. I'm going to circle this. 3 over negative 2. 3 divided by negative 2 is negative 1.5. We're going to take negative 1.5 times all of the top, 1 minus 3 to the 10. Okay? Just want to make sure you guys understood what I just did right there. I divided 3 by 3 is on top, negative 2 on bottom. 3 divided by negative 2 is negative 1.5. So negative 1.5 times 1 minus 3 to the 10. Now you need your calculators, okay? So let's type this in. And you're going to get a big number, a very big number, okay? So type in negative 1.5 parentheses 1 minus 3 to the 10th parentheses, and I have no idea. It's going to be a humongous number. I'm guessing in the tens of millions, perhaps. I don't even have any idea. So I'm going to get a calculator myself. Not that I don't trust you. I like to have more than one person. Close myself. You win. Take a boy. Okay, so Oh, it's not as big as I thought. It's less than 100,000.
You get 88,570.
That's what I got. I thought it'd be bigger than that. Huh, I thought it'd be much bigger than that. Okay, so what they're saying here is this. If you start with 3, and you keep multiplying by 3, you can do that for 10 numbers. If you add up those 10 numbers, you get 88,572, okay? Now, there's nothing wrong with what we just did right here, but I want to make sure, so you guys understand this. It's gonna be geometric if inside, or what you're plugging into the formula is raised, is exponential. If it's raised to the power of x, or raised to the power of k. Okay, it's gonna be geometric, okay? And what you need to understand is your base is always your rate, okay? Your base is always your rate. So if I gave you this right here, this is geometric because it's raised to the power of k, and your rate is 5. Your rate's 5, okay? That's the easy way to do it. So if you want to write out numbers, you can. If you want to, you can. You don't necessarily have to, though, okay? Let's look at question number 23. Okay? Go from 0 to 9. Negative 1/2 to k plus 1. Excuse me. Okay, so in this case, all right, the sum of, you got to be careful here, from 0 to 9. How many numbers is it from 0 to 9? It's actually 10. 1 to 9 is 9, so 0 to 9 is 10. So the sum of 10 numbers equals, to find our first term. To find our first term, we have to plug in 0. We're going from 0 to 9, so plug in 0. 0 plus 1 is 1. Negative half to the first is negative 1/2. So negative 1/2 times 1 minus your rate. Your rate is the base. Your base is negative 1/2. So minus negative 1/2 to the n over 1 minus negative 1/2. Okay, let's clean this up as best we can. So we have negative 1/2 times, and don't, you might be thinking, let's minus, make it plus, plus. You've got to do your powers first. You can't do anything with that. 1 minus negative 1/2 to the n. Minus, minus, plus, plus. That's 1/2. Okay. And let's do this. Let's simplify this right here. A negative divided by a positive is a negative. A half divided by 1/2. See if you guys remember this from trig. 1/2 divided by 1/2. Well, 1/2 is the same as 3/2. Remember from middle school, 2 times 1 plus 1? You guys remember what a half divided by 3/2 is from trig? What remembers that? You guys remember what 4/7 divided by 5/7 is? 4/5. How did I do that so quickly? If a fraction is divided by a fraction, the denominator is the same, get rid of them. So what's this? 1/3. Oh, and I keep putting n there. I'm sorry. What should I put in for n? 10. Okay. So let's type this in, see what we get. Okay? Watch all those negatives. There's a lot of negatives in this. Okay, so we have here. And if you're typing it in, I would type this in parentheses also. In parentheses, negative 1/3. That might make a difference. You're going to get a really small negative number, I think. Let me know what you get, because I might have typed it in wrong. Let me just make sure. think is right.
What'd you get?
What'd you get? Did you get less than 1?
Yeah.
0.333-ish?
Mm-hmm.
Yeah, it should be, is it negative?
Negative.
Negative 0.333007813-ish?
Mm-hmm.
Good. All right, so negative 0.333-ish. Don't need to put all those decimals. If you didn't get that and you're afraid to ask out loud, ask me later. Just make sure, I wanna make sure you can type it in right on the calculator. Okay, let's do some easy ones. Okay, much quicker, easy ones, okay? 25 we crossed off, 27. Much quicker, easy questions. So they simply want you to write this in summation notation, okay? So we look at number 27. They give us 2 up to 128, 2 plus 4 plus 8, 16, 32, 64, 128, okay? They don't want the sum. They want you to write it in summation notation. So let's do this. Okay, K equals, we have 1, 2, 3, 4, 5, 6, 7, 1, 2. So we can go from 1 to 7. From 1 to 7, okay? And then we just plug it into that formula, okay? The formula of each of the terms. Just pretend there was no plus signs here, okay? If I give you the numbers 2, 4, 8, 16, and so forth, you're gonna use this, is it up there? This formula right here, okay? So, G sub 1 is your first term, so your first term is 2 times, what's your rate? How are you going from 2 to 4, 4 to 8, 8 to 16, and so forth? Well, you times by 2, so times 2 to the, it says add, we're gonna use K minus 1. And that's it. You actually could simplify that though, okay? What we could do is this, and Alexis answered this the other day, might have been yesterday. 2 times 2 to the K minus 1, that's 2 to the first. You could just say it's what? Say it again. 2 to the K, right. This is fine, but 2 to the K would be fine, it'd be even better, actually. 29. Okay, one more of these, and we'll do some easier ones, much easier. You'll like what we do on the back. Okay, so 29. So we have 1/4 minus 1/12 plus 1/36 minus 108, 1 over 108. So, again, in this case, we're gonna go from K equals 1 to 1, 2, 3, 4, 1 to 4. Our first term is 1/4 times our rate. I think you can figure this out in your head. I mean, it's flip-flopping, so your rate's gonna be negative. So put negative. How do you go from 1 over 4 to 1 over 12? Times by, and be careful, some students say times by 3. Not by 3, times by 1 over 3. Right. Times by 1 over 3. They're not doing anything at the top. Your times the top by 1. So 1 negative 1/3. Your times the top by 1, which means it doesn't change, times the bottom by 3, and it's negative because it flip-flops to the K minus 1 power. Okay, and the answer is whatever that is. Okay. Something we haven't talked about. I gave you the formula. I haven't talked about it yet, though, okay? Let's knock out these last, 4 questions that we've done for today. It says, find the sum of the infinite geometric series if it exists. If it exists, okay? Just want to make sure. Okay, yeah. So on number 31, the formula I gave you, because they don't all have an answer. They don't necessarily exist, okay? I mean, for example, if I give you this right here, 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus. Well, if I just stop right there, that obviously has an answer. If I put plus dot, 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 that means it goes on forever. There is no solution. I mean, the answer is infinity. Because you keep adding on numbers, we're adding on numbers that are getting bigger. If you keep adding on numbers to get bigger, I mean, it's kind of like this. Let's use an unrealistic situation. Let's say that you're jogging and you're very ambitious, okay? And every day you double the amount that you run the day before. Well, I mean, if you add up all the miles you ran 1 mile, then the next day you ran 2 miles, next day you ran 4. I mean, realistically, a human being can't run 512 miles in a day. They can't do it. It's not possible, okay? But let's just pretend you could, okay? Well, if you keep adding up the amount of mileage, it's just gonna get bigger and bigger and bigger and bigger and bigger, okay? But what if you have somebody who's lazy? They're gonna say, I'm gonna take half of what I did every day. So I started out with 10 miles today, 5 miles tomorrow, 2.5 miles the next day, 1.25 miles the next day. I mean, I'm keep adding on numbers, but I'm adding on numbers that are getting smaller. Okay, it's approaching 0. Pretty soon I'm gonna be jogging less than an inch. Okay, so you're adding on. It's like walking across the room. Okay, I keep adding on numbers, but I'm adding on numbers that are getting smaller. Okay, so what you need to understand is for an infinite geometric series, in order to actually have a limit on it, you got to keep adding on numbers, but adding on numbers are getting smaller. So your rate's got to be smaller than 1. Okay, it's got to be smaller than 1. All right. So let's look at number 31. 31. So we have, what are the numbers here? 1, negative half, 1 minus a half, plus a fourth, minus an eighth. Is that what it says? Plus something. Okay, so we're adding on numbers. If you ignore the pluses and minuses, the numbers are getting smaller. A half, a fourth, an eighth, a 16th. So, well, here's what we're going to do. The formula for the sum of an infinite series I gave you was g sub 1 over 1 minus r. Well, no matter what, you've got to find the rate anyhow, okay? You got to find the rate. So to find the rate, take any number, divide by the one in front of them. I'm going to take negative half and divide by 1. So it's a negative half, okay? What I told you to write down was the absolute value of r has to be less than 1. So it's got to be somewhere. Another way of saying that is it's got to be somewhere between negative 1 and positive 1. That's another way of saying it. Your rate's got to be somewhere between 1 and negative 1. So does this sum exist? Does it exist? Yeah, because your rate is between 1 and negative 1. Well, let's find out what it is, okay? So we take g sub 1, which is 1, over 1 minus your rate. Your rate is negative 1/2. Minus minus, plus plus, so it's 1 over 1 plus a half, that's 1 1/2. Okay, and if you type in 1 divided by 1 1/2 on a calculator, you come up with 2/3. You get 0.6 repeating, it's 2/3, okay? So what we're saying is, if you start with 1 and you keep timesing by negative half, you're gonna eventually get 2/3. This is where it gets really wiggy, okay? You're gonna get eventually 2/3 if you add up how many numbers. An infinite number of numbers, okay? So again, can you do that? Realistically, no. But, I mean, it's like, again, walking across the room, okay? I keep adding on numbers, but you know I'm never going to get to that's the other side, okay? So we'll use that example right now. It's 40 feet total, okay? So the first day I walk 20 feet. The next day I walk 10 feet. The next day I walk 5 feet. The next day I walk 2.5 feet. I do that forever, okay? You know the answer is going to be 40 because the room is 40 feet. I have to walk an infinite number of days in order to get there, okay? But it's going to be 40. So in this case, g sub 1 over 1 minus r, g sub 1 is 20 over 1 minus my rate. My rate is a half. 20 over 1 minus a half is a half. How many half dollars are in $20? 40. There it is, okay? All right, let's try 33. I would hope 33 is an easy one for you. Just by looking at it, do you think it exists or not? How come? The numbers keep getting smaller, okay? You're adding on numbers that keep getting smaller, okay? All right, so on this one, 33, they give us 1.5 plus 0.015 plus 0.3015. And you know it's infinite because of the 3 dots. Okay, they tell you it's infinite. There's 3 dots there. Okay, so let's find our rate. To find our rate, we take 0.015 divided by 1.5. Okay? Excuse me. If you do that, you're going to get, what I'm going to get here is 0.01. 0.01. Right? So, yeah, 0.01. That's our rate. So, the sum of this infinite series is our first term, 1.5, over 1 minus our rate, 0.01. So 1.5 over $1 minus a penny is 99 cents. Let's punch that in. What's 1.5 divided by 0.99? You get 1.51 repeating, I got. Well, that makes sense. That's so stupid, I can't believe I did that. Because look at this. All they're doing, and this ties into what we're gonna be doing tomorrow, if we're here tomorrow. All they're doing is moving a decimal 2 spots to the left, 2 spots to the left, 2 to the left. If I line these up, 0.5, 0.015, 0.00015. If I was to add these up, we're gonna have 1.515. There's zeros in front of, on top of these. You're gonna have 1, 5. It's just gonna be 1, 5, 5, 1, 5, 1, 5, 1, 5, 1 forever. That ties in exactly what we're gonna be doing tomorrow. I can't believe I didn't see that. Okay, 2 more, I think. Yep, 2 more. Sort of 2 more. You'll see why here in a second. Okay, 35. Went from radical 2 minus 2 plus radical 8 minus 4. Okay, plus. Okay. Now, this is where it's a little bit tricky though, okay? Are the numbers getting bigger or smaller? Can't really answer that. Because we have a positive number down to a negative number, up to a bigger positive number, down to a smaller, I mean, it goes plus minus, okay? So let's do this, okay? But if you ignore the signs, here's a little trick. If you ignore the signs, the numbers are getting bigger, okay? So there's not gonna be an answer to this one, okay? It's not gonna be the answer. So let's actually show this. To find our rate, take any number, -2, and divide by the one in front of it, radical 2. I don't know if we've talked about this at all this year. Is that okay for an answer? No, times by radical 2. -2 times radical 2 is -2 radical 2. Radical 2 times radical 2 is radical 2, which is 4. I'm sorry, radical 4, which is 2. These 2's cancel, and you get negative radical 2. That's our rate. I don't know exactly what the square root of 2 is. I know the square root of 1. Square root of 1's 1. So square root of 2's gotta be what? Bigger than 1. So since your rate is bigger than 1, it's gotta be between 1 and -1. It's actually smaller than -1, that's what I should say. There is no, what do they ask for? What is the sum? There is no sum. Okay? You're gonna keep adding on bigger positive numbers and bigger negative numbers, just continually getting bigger and smaller, or bigger positive numbers and bigger negative numbers. There is no sum there, okay? Just like if the person kept doubling the amount of miles they run, your sum's just gonna get, it's gonna get bigger and bigger and bigger. It doesn't approach anything, okay? Last one, 37. 256, 192, it's 192 plus 144 and 108. Hopefully this is easy enough to tell that there definitely is a limit on this. There actually is a sum because the numbers are getting smaller. Let's find out what our rate is. Take 192 divided by 256. And that simplifies what goes into those. Let's just divide it out. I think 16 goes into them. You get 0.75, you get 3/4. That simplifies to 3/4. So again, we knew that there was going to be an answer because the numbers are getting smaller. Now we definitely know there's getting an answer because our rate is less than 1. It's 3/4. If it was 4/3, there would be no answer. Okay, so we take g sub 1, 256, over 1 minus our rate, which is 3/4. So 256 over $1 take away 3/4 is 1/4. You take 256 and divide it by 1/4, 256 divided by 0.25, you get 1024. I'll show you how I did that in my head. Dividing by 1/4, if you remember from middle school, the same as 256 times 4 over 1, which is just 4. What's 4 times 256? Forget the 6. What's 4 times 250? What's $250 and $250 and $250, $250? $1,000. What's 4 times 6? 1,024. Or use calculator. Or use your phones if they have the phones, your calculators on your phones, right? Yeah, they have those on there. Okay, all set for today? Okay, easy stuff tomorrow, if we're here tomorrow.
We're gonna